All right, here in your second video, we're going to talk about rules for differentiation. So we're going to go back over a lot of the rules that you already learned in pre-cal and then throw in two more that you'll need to know next year in calculus. Okay, so the first rule is the derivative of a constant rule. So if c is any constant, then the derivative with respect to x of that constant c is just equal to 0. And so that really shouldn't be earth-shattering to anybody because remember, one of the major interpretations of the derivative is slope of a tangent line. So if I were to graph a tangent line, or I'm sorry, a horizontal line, okay, so like say right here at y equals to c, then the slope of that line is 0. And remember, if the derivative means slope of the tangent line, then all of the tangent lines to this function have a slope of 0. Okay, so example 1, a and b are really not really overly hard. If f of x is equal to 5, then f prime of x, which is how I denote the derivative, is equal to 0. And then in part B, it's meant to kind of be a little bit of a trick. It says pi squared. Don't start thinking that that's a power rule problem because remember that pi is a constant. So if I square it, it's still a constant. And so if it's a constant, then that means that its derivative is equal to 0. Okay, so pretty straightforward there. Derivative of any constant is just 0. Okay, the power rule deals with x's being raised to some exponent, so x to the n, the derivative of this. Okay, remember from pre-cal, I'm going to move the exponent into the front, and then I'm going to multiply by x to the n minus 1, subtracting 1 from the exponent. Okay, so that is the power rule. And then the sum and difference rule just says that I can take the derivative of multiple terms, and it's just the derivative of those terms. So what I mean by that is if I have d over dx of f of x plus or minus g of x, that's just equal to f prime of x, and then either plus or minus g prime of x. Okay, so in example 2, we're just going to do some basic derivative problems. Okay, so in part A, I have f of x is equal to 6x cubed minus 4x squared plus 2x minus 9. So if I use the power rule here, the derivative f prime of x is going to equal, I'm going to bring the 3 into the front, multiply it with the 6, that's going to give me 18, x to the second, because I reduce the power by 1 whenever I use the power rule, minus, bring the 2 in the front here and multiply it with the 4, so that's going to give me 8. And then x to the first power. I'm not going to write the 1 since typically we're not going to do that if it's raised to the first power. And then the derivative of 2x, whenever I take the derivative of a term like that, the x is just going to drop off, and then the derivative of negative 9, of course, is 0. Okay, in part B, this is a rational function, and so what I'm going to do before I can use the power rule is I'm going to split through the numerator so that I can actually utilize the power rule. Now I know that you guys know the quotient rule, and we are going to talk about the quotient rule a little bit later on in these notes, but the quotient rule doesn't always have to be used. Whenever you can split through the numerator like this, you don't have to worry about using the quotient rule, and sometimes it's a lot easier to actually avoid the quotient rule altogether. So I'm going to split through the numerator by putting the 3x under all of the terms in the numerator, and that's going to simplify to 8/3 x squared plus 5/3 x minus 4/3. Now I haven't done any calculus yet. This is still f of x. Okay, so all I've done so far is algebra to try and make the problem into a form that I can actually utilize the power rule. So now that it's in that form, I can go ahead and take the derivative. F prime of x is going to equal, I'm going to move the 2 into the front, multiply it by the 8/3 to get 16/3 x to the first power, plus the derivative of 5/3 x, which is just 5/3, and then the derivative of a constant, negative 4/3, of course, is just 0. So here is my answer to example B. Okay, in example C, we have g of x is equal to 4 over the square root of x. This radical notation, this square root notation, is really not any good for us ever. And so anytime you see that notation, you're going to want to switch out of it so that you can actually do the calculus and get the answer. So I'm going to change that into exponential form. Since it's in the denominator, I know that when I move it to the numerator, the exponent is going to become negative. So this is going to actually be 4x to the negative, and then if it's square root, I know that the exponent is 1/2. Okay, so I'm going to rewrite it in that form. That's going to allow me to use the power rule. So g prime of x is going to equal to 4 times negative 1/2 is -2, x to the -3/2, okay, which if I were to write back into radical form would be -2 divided by the square root of x cubed. Okay, and then in example D, this is very similar to example B. I'm again going to have to split through the numerator. So before I do any calculus, I'm going to rewrite this as 8x to the 4th divided by x squared minus 6x cubed divided by x squared, and then plus pi over x squared, which I'm then going to simplify to say 8x squared minus 6x plus, for this term, this pi over x squared term, I'm going to rewrite it as pi x to the -2. Okay, so since there's no x in the numerator, I'm just going to bring that x squared to the numerator and make the exponent negative. Okay, again, haven't done any calculus yet, so this is still f of x. And now when I use the power rule, I'm going to get f prime of x is equal to 16x minus 6 minus 2 pi x to the -3. Okay, so this is the answer. The only real thing that you could do if you wanted to is on that last term, you could put that x to the -3 back into the denominator, but just make sure that when you do that, it only goes to the denominator of that particular term. So as you see, as I've written the final answer, the x cubed is only under the 2 pi and not under the entire problem. Okay, so that's the power rule. We're now going to move into talking about the chain rule. Okay, so this is basically just some information and some review for you of composite functions. So I'm going to let you read that on your own, and not really going to talk too much about that. Now, there are kind of two versions of the chain rule. There's the chain rule that helps you take the derivative of polynomial functions, okay, which is the one that's right here. And then there's the general chain rule that allows you to take the derivative of any composite function, whether it's a polynomial or trig or exponential or whatever the case may be. So that's the way that your calculus textbook writes it, and that's the way I'm going to want you to have it memorized. Okay, so the general chain rule says the derivative with respect to x of f of g of x. So make sure you recognize this is not a product. This is g of x inside of another function f of x. Okay, so not f times g. We'll talk about what to do when it's f times g a little bit later on in these notes, but right now we're talking about f of g of x. And when I take the derivative of that, I take the derivative first of all of the outside function, so that is f prime of g of x, and then the chain rule part is multiplying by the derivative of the inside, which is going to be represented by g prime of x. Now that's the part that everybody forgets about, so you've got to be very sure that you don't forget about multiplying by the derivative of the inside function. Okay, so example 3, it says find the derivative of the function. We've got this 4x cubed plus 3x minus 2 inside of a function to the 5th power. Okay, so that's how I know that it's a chain rule problem. So I'm going to first of all start off by taking the derivative of the outside function, which is the 5th. So I'm going to take the 5 and I'm going to move it in front. I am going to rewrite the inside just the way that I see it. So 4x cubed plus 3x minus 2 to the 4th power, and then times the derivative of the inside, making sure that I put it in parentheses. So the derivative of the inside using the power rule is going to be 12x squared plus 3. Okay, and that's perfectly fine as your final answer. Okay, example B, y is equal to x to the 4th plus 2 to the 2/3 power. Again, this is a chain rule problem because I have a function inside of another function. I have x to the 4th plus 2 inside of x to the 2/3, if you want to think about it like that. Okay, so the outside function is to the 2/3 power, so y prime is going to equal 2/3. Rewrite the inside just the way that you see it, x to the 4th plus 2, multiplied by, or I'm sorry, raised to 2/3 minus 1, which is negative 1/3. Okay, and then I'm going to try to maybe zoom out here if I can so that I can write the derivative of the inside piece. Okay, so the derivative of the inside piece is going to say 4x cubed. Okay, so times 4x cubed. Okay, now if I wanted to clean that up and make it look like something that might resemble the final answer, what's going to be in the numerator? Well, in the numerator, I'm going to have this 4x cubed, and I'm also going to have this 2. So if I multiply those together, that's going to give me 8x cubed. And in the denominator, I'm going to have a 3, which comes from right here. So this 3 is going to go down here. And then this x to the 4th plus 2 term has a negative exponent on it. So if I move that to the denominator, it's going to say x to the 4th plus 2 to the positive 1/3. Okay, so this right here looks pretty good as my final answer. Okay, so I'm going to try to come back over here and go on to the next page of the notes. Okay, so before we go any further, it's best to just introduce the derivative rules of all the rest of the functions that you're going to need to know about. And so here they are. You just need to have them memorized. In my class and on the AP exam, there is no formula chart, and so I basically just expect you to have these memorized. Once we kind of develop them in class, we'll start having pop quizzes that kind of test your knowledge and your memorization skills of these rules. Okay, so you just need to make sure that you begin to memorize these rules. Okay, so I'm going to demonstrate a couple of them through example here. So our first example says sine cubed of 4x. What I need to recognize about this is that this is a chain rule problem. Okay, so the reason that this is a chain rule is because the cubed is the outside function, and sine is the next function, and then 4x is the innermost function. And so really, the way that it can be helpful for you to see this is sine of 4x and then all cubed. And I think writing it like that helps you realize, okay, yes, this is a chain rule problem where x cubed is the outside function and sine of 4x is the inside function. Okay, so f prime of x is going to equal, I'm going to bring the 3 into the front. I'm going to rewrite the inside exactly the way that I see it. So that's going to be sine of 4x, and then that's going to be raised to the 2nd power. So I'm going to put the 2 right there. And sorry about these stray marks that keep popping up because of my wrist. Then I'm going to multiply times the derivative of sine of 4x. And if you look back up at your rules, the derivative of that is going to be cosine of 4x multiplied by 4. Okay, really the only thing to do in order to make this look complete is to multiply the 3 times the 4. So 3 times 4 is 12. Sine squared of 4x multiplied by cosine of 4x, and there you have it. That is your final answer. Okay, example B says the square root of cosine of x. This again is a chain rule problem because cosine is inside of the square root. Remember, anytime we see this square root, we're going to want to rewrite it so that it makes a little bit more sense. So I'm going to rewrite it as cosine of x to the 1/2. That way I can see exactly what I need to do when I use the power rule. So g prime of x, I'm going to take the 1/2, I'm going to move it into the front. I'm going to rewrite cosine x to the negative 1/2 power, and then multiply by the derivative of cosine x, which is negative sine of x. Okay, if I'm going to rewrite this as the final answer, the only thing that can go in the numerator is the negative sine of x part. So negative sine x will go in the numerator, and then that will be divided by 2 cosine x to the 1/2 power, because again, this has a negative exponent on it, which means I can send it to the denominator. And I'm just going to go ahead and rewrite that in the radical notation as the square root of cosine x. Okay, Example C says h of x is equal to the natural log of x squared plus 1. So if you look back up at your rules, the rule for natural log is u prime over u, where we think of this x squared plus 1 as our u. And so the derivative, h prime of x, is going to be u prime, and the derivative of x squared plus 1 is 2x, divided by u, which is x squared plus 1. And there's really nothing else to do there. That is the final answer. Okay, and then example D says f of x is equal to sine inverse of 5x. Now let me just say very clearly here, this is not equal to 1 over sine of 5x. This is known as sine inverse of 5x. It's a different function than the reciprocal. Remember, the reciprocal of sine is cosecant. And so we're not talking about the reciprocal right here. We're talking about the inverse sine. Another way that you might see this problem is as follows. You might see it as arc sine of 5x. And so you need to know that those two things mean the same thing. Okay, so the rule for arc sine or sine inverse is u prime over the square root of 1 minus u squared. So in this case, our u is 5x, so the du, or u prime, is going to be 5, so that's what's going to be in the numerator, divided by the square root of 1 minus u squared. Well, if I square 5x, that's going to be 25x squared. Okay, so the common mistake there is that people will only square the x and not the 5 as well, and so you don't want to put 1 minus 5x squared. You want to make sure that you square all of 5x. Okay, so let's move on to example E. Example E is more of what I would call a conceptual type question that you might see on the AP exam. So it says, let h be a differentiable function. We'll talk more about what that means in class. For right now, you just need to know that that means we're able to take the derivative of the function h. And let f be defined by f of x is equal to h of x squared minus 3. So you need to recognize this is a composite function. It is not a product. Whoops, not really sure what happened there with the highlighter. Tried to just highlight the function. There we go. Okay, so it's a composite function. It is not a product. It is not h times x squared minus 3. It is h of x squared minus 3. Okay, and so the question is asking, what is f prime of 2? Well, if I take the derivative here, this is a chain rule problem because x squared minus 3 is inside of h of x. Okay, so f prime of x is going to equal to the derivative of the outside, which is h prime, evaluated at the inside, which is just x squared minus 3, and then multiplied by the derivative of the inside, which is 2x. Okay, well, the problem is asking me for f prime of 2. So if I plug in 2 for x, then f prime of 2 is equal to h prime of 2 squared minus 3. Well, I know that 2 squared is 4, minus 3 is 1, and then times 2x, but x is 2, so that's going to be 4. And so my final answer is going to say 4 times h prime of 1. Okay, and so that was an old multiple choice question on a previous AP test, basically just testing whether or not you knew how to apply the chain rule. Okay, the last couple of important rules here that we're going to talk about are the product rule and the quotient rule. Both of these were discussed in pre-cal, so this should really just be review for you. The product rule says this: the derivative with respect to x of f of x times g of x. If I call this the first function, and I call this one the second function, then really what this says is the first multiplied by the derivative of the second, and again, sorry about the stray drawings over there, the first times the derivative of the second plus the second, g of x, times the derivative of the first, f prime of x. Okay, so again, I'm not going to allow you to have that on any sort of a note card. That's just going to have to be memorized. And I'll give you some techniques in class to help you memorize it if you're having trouble. Okay, the quotient rule is also something that needs to be memorized. So for the quotient rule, this is kind of how I do it, and just to make it easy, I call f of x the high function and g of x the low function. Okay, so the quotient rule says the derivative of f divided by g is low, which is g of x, times the derivative of the high. So that would be f prime of x, minus high, which is f of x, times d low, which would be g prime of x, and then please don't forget all over low squared. So the low is going to be g of x, all of it squared. Okay, so low d high minus high d low all over low squared, and make sure that you have it memorized at some point. Okay, so example 5, we're going to utilize the product and the quotient rules in order to find some derivatives. So the first problem says 2x times cosine of x. So hopefully you notice that the 2x is the first function, cosine of x is the second function. So in this case, we are going to use the product rule because this is a function multiplied by another function, 2x times cosine of x. Okay, so the product rule says the first, which is 2x, multiplied by the derivative of the second, the derivative of cosine x is negative sine x, plus the second, which is cosine x, multiplied by the derivative of the first, and the derivative of 2x is just 2. Okay, if I was to clean that up a little bit, I could factor out a 2, and so I'm going to go ahead and do that from both terms. So 2, and then I'm going to be left with, in the first term, a negative x sine x plus a cosine x. Okay, and there is my final answer for example A. Okay, let's go to example B. I have x multiplied by the square root of 2x minus 1. Again, I don't really like this square root notation, so I'm going to rewrite this as x times 2x minus 1 to the 1/2. Okay, so if I utilize the product rule here, since this is a product of two functions, I'm going to have the first multiplied by the derivative of the second. So the second is 2x minus 1 to the 1/2. The derivative of that is 1/2 2x minus 1 to the negative 1/2. Multiplied by 2 because of the chain rule. So that 2 comes from the derivative of the inside, which is 2x minus 1. Okay, the next thing the product rule says is plus the second, which is 2x minus 1 to the 1/2, times the derivative of the first. Well, the first function is x, and so I'm going to multiply by 1 since the derivative of x is just 1. Okay, now this is not anywhere close to what the final form of the answer needs to look like. So here's what I'm going to do, and this is what you should notice. You should notice that both of these terms have a 2x minus 1 in them. So what I'm going to do is factor out a 2x minus 1. Now the question is, how many 2x minus 1s can I factor out? The answer to that question is this. You can only factor out what you have the least amount of. Okay, so if I look at the two exponents here, the two exponents are negative 1/2 right there and positive 1/2 right there. The smaller exponent is negative 1/2. So that is what I am able to factor out. I put a negative 1/2 right there. Okay, then I see what is left over from both terms. Well, what I noticed from the first term is that the 1/2 and the 2 are going to cancel, so I'm not going to worry about those. So I see what I have left over is x. And then this term right here, the 2x minus 1 to the negative 1/2, was already factored out. So really, the only thing left over from that first term is x. Now, from the second term, this is where it gets a little bit tricky. I started out with a 2x minus 1 to the 1/2. I took away negative 1/2 of those. Okay, so if you think back to elementary school, your elementary school teachers tried to explain subtraction as taking away or adding the opposite, however you want to think about that. So if I add the opposite or I take away negative 1/2 from 1/2, what I'm really doing is adding 1/2 plus 1/2. And so 1/2 plus 1/2, of course, is 1. And so really what I'm left with is just 2x minus 1 to the first power. Okay, and if that doesn't make sense to you, that's okay. I can explain it more to you in person and maybe in a more one-on-one setting. But why don't you verify for yourself? Pause the video if you need to, and just multiply back through by the 2x minus 1 to the 1/2 here, and just make sure that you end up with what you started. And I think you'll see that that 1 as the exponent right here is correct. Okay, so as the final answer, what we're going to end up having is in the denominator, we're going to have the square root of 2x minus 1. Since that was a negative 1/2 power, it goes to the denominator. And the 1/2 power means that it's a square root. And then in the numerator, we're going to collect our like terms. And so we're going to have 3x minus 1 in the numerator. And there's our final answer. Okay, so that example was a little bit tricky. If you have questions on that one, please feel free to ask me. I think I did put one similar to this one on your assignment. So we got to make sure that we're able to do a problem like that. Okay, example C says, f of x is equal to 5x minus 2 over x squared plus 1. So this is a classic quotient rule problem. This is not like the problems way back in the beginning of the notes where I could split through the numerator. And the reason I can't do that is because there are multiple terms in the denominator. Okay, so what I'm going to have to do is utilize the quotient rule. So f prime of x is equal to low, which is x squared plus 1. And what I want you to notice is that I'm putting that in parentheses, okay, so that I know that everything is going to be multiplied by the derivative of the top. So the derivative of the top is 5, minus high, which is 5x minus 2, times the derivative of the bottom, which is 2x. Okay, so low d high minus high d low, and then all over, please do not forget this part, all over low squared. So that's going to say x squared plus 1 squared. Okay, what's going to end up happening now is that I'm going to do some algebra and some distributing in the numerator. And so what's going to end up happening is I'm going to have this 5 multiplied by the x squared and the 1. So that's going to be 5x squared plus 5. And then this 2x is going to get multiplied by both of these terms. And then because this minus sign is right here, I'm going to end up changing the signs of both of those terms. Okay, so let's see if you can follow along here. I have 5x times 2x, which is a 10x squared. But because the minus sign is right there, it's going to be a minus 10x squared. And then if I do negative 2 times 2x, these two terms multiplied together, that's negative 4x. But because the minus sign was right here, it's really going to be a positive 4x. Okay, don't forget your denominator. That can't disappear on you, so that's going to say x squared plus 1 squared. And then the last thing I'm going to do is collect the like terms to get the final answer. So this is going to say negative 5x squared plus 4x plus 5, and then all over the denominator squared, x squared plus 1 squared. Okay, last example here is a combination of the chain rule with the quotient rule. So the reason for that is because we have a function inside of another function. The quotient, 3x minus 1 over x squared plus 3, is inside of a square. Okay, so if I take the derivative, h prime of x, the first thing that I need to deal with is the square. So I'm going to bring the 2 into the front, rewrite the parentheses just the way that I see them. So 3x minus 1 over x squared plus 3. That, of course, would be to the first power since I reduced the exponent by 1. And then I'm going to multiply by the derivative of the parentheses, or the inside function, and that's going to require the quotient rule. All right, so the quotient rule says low, which is x squared plus 3, d high, which of course is 3, minus high, 3x minus 1, multiplied by the derivative of low, so that's going to be 2x, all over low squared. So that'll be x squared plus 3 squared. We'll close the parentheses there. Okay, so if I go ahead and clean everything up here, what I end up having is a 2, a 3x minus 1 in the numerator. So the 2 is this 2, the 3x minus 1 is this 3x minus 1. And then in the final parentheses, I'm going to go ahead and clean up what I have in here. So I'm going to distribute the 3 to both of those terms. That's going to give me 3x squared plus 9. Minus, if I multiply 3x and 2x, that's going to give me 6x squared. And then 2x and minus 1 gives me negative 1, but because there's a minus sign right here, I've got to multiply that by negative 1, so it ends up becoming positive 2x. Okay, don't forget your denominator, so this is going to be all over. Now the question is, how many x squared plus 3's do I have? So I know that I have that in the denominator, but how many of them do I have? Well, there's one of them right here. Okay, so let me use the highlighter so that you can see that. That's right there. There's one of them. And then there are two of them sitting right here. So if I combine those, that's going to give me a grand total of 3 of them. And so that's what the exponent becomes. And then the last thing I need to do is collect the like terms in this final parentheses that's right here. Okay, so if I collect those like terms, rewrite everything that I have down. So 2 times 3x minus 1. And then multiplied by what? Negative 3x squared plus 2x plus 9 all over x squared plus 3 cubed. Okay, and there is my final answer for that. Okay, final page of the notes here, example 6. These are very typical problems that you'll see on the AP exam, possibly on multiple choice, also possible on free response as well. And so we want to make sure that we know how to do these symbolic type problems. Okay, so using this table and these functions that they give us, we want to find these derivatives. So if h of x is equal to f of x times g of x plus f of x divided by g of x, then find h prime of 5. Well, in order to find h prime of 5, the first thing I need to do is find h prime of x. So if I do this term by term, the first term I'm taking the derivative of is this f of x times g of x. Well, that's a product, and so in order to take the derivative of a product, I have to use the product rule. And so the product rule says the first times the derivative of the second plus the second times the derivative of the first. And so there is my derivative of that product portion of h of x. The second portion of h of x is this quotient. And so in order to take the derivative of that quotient, I have to use, of course, the quotient rule. And so what the quotient rule says is low d high minus, I'm going to try to fit this in on the screen, minus high, which is f of x, multiplied by d low, which is g prime of x, all over low squared. So that's going to be g of x quantity squared. Okay, the next step would be plugging 5 into all of these x's. Okay, I think you guys can probably do that on your own. And so what I'm going to do is I'm just going to go ahead and skip to calculating the values by plugging in from the table. So h prime of 5 is going to equal, the first thing is going to be f of 5. So f of 5, if I look at the table, is 3. Multiplied by g prime of 5, and g prime of 5 is negative 2. Okay, getting those numbers from the table. Plus g of 5. G of 5, I'm sorry, I made a mistake here, didn't I? So let's back up. G prime of 5 is 5, not negative 2. So 3 times 5 plus g of 5, which is negative 2. Sorry about that. And f prime of 5 is 4. Okay, so there's the first part. And now I'm going to go ahead and plug into the second part of this. So again, g of 5 is negative 2. F prime of 5 is 4. Minus f of 5, which we said earlier was 3. And then g prime of 5, which was 5, all over g of x squared. And g of 5 is negative 2. And then make sure that you square it. Okay, so if we do the arithmetic here, and yes, you need to be able to do this without your calculator. This is going to be 15 minus 8 plus negative 8 minus 15 all over 4. And so what we end up getting here is the following. We have 15 minus 8, which is 7, and then basically minus 23 over 4. 7, of course, is 28 over 4, minus 23 over 4, and so our final answer is 5/4. Okay, so yes, you need to be able to do a little bit of arithmetic on your own. without a calculator. So it's good for you to practice those things now. You should be doing most of these assignments, all but one of them really, without the use of your calculator. Okay, so example A is done. We're going to move on to example B. It says if h of x is now a different function, f of g of 2x. Okay, so please make sure that you recognize this right here is not a product. That is a composite function, which means we're going to be using the chain rule. So h prime of x is equal to the derivative of the outside, which is just f prime. Rewrite the inside exactly the way that you see it, which would be g of 2x multiplied by the derivative of g of 2x, which is going to be g prime of 2x. And then I have to remember to take the derivative of the inside of that function, and the derivative of 2x is 2. Okay, so if I go ahead and plug in 2 here, since it's asking me to find h prime of 2, then that's going to say what? I'm going to move the 2 to the front to make that a little easier. And then this is going to be f prime of g of 2 times 2 is 4. Okay, so I'm just kind of skipping a step there, making this x a 2, and 2 times 2 is 4, times g prime of 4. Okay, so if I go to the table to find these values, this is going to be 2 times f prime of g of 4, and it says that g of 4 is 3. Multiplied by g prime of 4, and so that's going to be 2. F prime of 3, if I look up at the table, is -5, and g prime of 4 is 9, and if you multiply all of that together, then you should be getting -90. Okay, so there is example B. Last example for this video, so this is going to be a little tough. We might have to do some scrolling back and forth between the table and the problem, but it's okay, we'll survive. Okay, so we have h of x is equal to g of x quantity squared. So again, very similar to example B, this is a chain rule problem because I have a function g of x inside of another function, which is a square. Okay, so if I take the derivative of this h of x, then h prime of x is going to equal to 2. Rewrite the parentheses, or in this case the brackets, and that would be to the first power, so I'm not going to write anything there. And then don't forget to multiply by the derivative of the inside, which is g prime of x. Okay, so h prime of 3, I'm going to substitute in 3's. So 2 times g of 3 times g prime of 3. And if I go back up to the table, g of 3 and g prime of 3 are what I need. So g of 3 is 6, and g prime of 3 is 2. And so 2 times 6, and I already forgot what it was, so I have to go back. Sorry about that, is 2. And so 2 times 6 times 2 is 24. Okay, so hopefully you guys have enough information now to tackle the assignment. And if you have any questions, then please let me know.